Today we are going to see the converse of Rolle's theorem. So what is converse of Rolle's theorem? Before that, what is Rolle's theorem? So Rolle's theorem states that if a function f of x is continuous, f of x is differentiable and f of a is equal to f of b, then there exists a point c belongs to a comma b such that f dash of c is equal to 0. Now what is converse of Rolle's theorem? Converse of Rolle's theorem is, let P1 be f of x is continuous in closed interval a comma b and f of x is differentiable in open interval a comma b, and if f dash of c is equal to 0 such that c belongs to a comma b, then f of a is equal to f of b. That is, the function is continuous and differentiable and f dash of c is equal to 0 such that c belongs to a comma b, then f of a must be equal to f of b. So for that, let us see an example first. Let us take an example. F of x is equal to x cube in the interval minus 2 comma 2. Now x cube is a polynomial function. So f of x is a polynomial function. Therefore, polynomial functions are continuous. So f of x is continuous in closed interval minus 2 comma 2. F of x is differentiable in open interval minus 2 comma 2. So f dash of x, let us find f dash of x. What is f dash of x? F of x is x cube. Therefore, f dash of x is equal to 3 into x square. So what is f dash of c? So f dash of c is 3 into c square. So f dash of c is equal to 0. Then 3c square is equal to 0. So c square is equal to 0 by 3. So c is equal to 0. So 0 is belongs to minus 2 comma 2. So all conditions are satisfied. Now we have to check whether f of a is equal to f of b. Here f of x is equal to x cube. So now check f of minus 2. F of minus 2 is equal to minus 2 cube, that is minus 8. What is f of 2? F of 2 is 2 cube, that is plus 8. So f of minus 2 is not equal to f of 2. So converse of Rolle's theorem is not true, because in this problem it is continuous, differentiable, and also f dash of c is exist and the point c belongs to minus 2 comma 2, but f of a is not equal to f of b. So converse of Rolle's theorem is not true. I hope you understand this problem. Thank you. Let us see another example for converse of Rolle's theorem. F of x is equal to x square plus 3x plus 7 in the interval minus 2 comma 2. Here f of x is again a polynomial function. So polynomial functions are continuous. So it is continuous in minus 2 comma 2. Also it is differentiable in open interval minus 2 comma 2. Now we have to find f dash of x. So f dash of x is 2x plus 3. Now f dash of c is equal to 2 into c plus 3. Now equate it 0. So f dash of c is equal to 0. So 2c plus 3 equal to 0. So 2c is equal to minus 3. So c is equal to minus 3 by 2. So minus 3 by 2 belongs to the interval minus 2 comma 2. Now f of x is x square plus 3x plus 7. We have to check whether f of minus 2 is equal to f of 2. So f of minus 2 is minus 2 square, 3 into minus 2 plus 7. So 4 plus minus 6 plus 7 gives 5. Then what is f of 2? F of 2 is 2 square plus 3 into 2 plus 7. So 4 plus 6 plus 7 equal to 17. So f of minus 2 is not equal to f of 2. So converse of Rolle's theorem is not true. In this problem, the function is continuous, differentiable and f dash of x exists and that point C belongs to a comma b, but f of a is not equal to f of b. So converse of Rolle's theorem is not true. I hope you understand this problem. Thank you.